Lesson 12.5, Mean as Fair Share and Balance Point. Essential question, how does the mean represent a fair share and balance point? Investigate. Materials. Counters. On an archaeological dig, 5 students found 1, 5, 7, 3, and 4 arrowheads. The students agreed to divide the arrowheads evenly. How many arrowheads should each student get? A. Use counters to show how many arrowheads each of the 5 students found. Use 1 stack of counters for each student. So what you're going to do is you would take each number found and add them all together. Put them all in the same pile, and then you're going to equally divide them among the 5 different kids. Remove the counter from the tallest stack and move it to the shortest. Keep moving the counters from taller stacks to shorter stacks until each stack has the exact same height. So then you count all of the numbers of counters in each stack. The number of counters in each stack is the mean or average. So this word here means average of the data. The mean represents the number of arrowheads each student should get if the arrowheads are shared equally. So remember, the number has to be equal. 1, 5, 7, 3, and 4 were each of the numbers of the arrowheads that each student found. So how I'm going to find the average, I'm going to add all of these numbers up to find the total number that all of them found together. So 1 and 5 is 6. Let's do this. 1 and 4 go together to get 5. And then 5 and 5 equals 10. So then we have 7 and 3 also equal 10. So we have 10 plus 10. Your total number is 20. So then you're going to take the 20 arrowheads that each of them found and then divide it by 5, the total number of students, which would give us 4. So there are 5 stacks of 4 counters, so each student should get 4 arrowheads. Number 1, drawing conclusions. Explain what is the fair or about a fair share of a group of items. So when items are shared fairly, each share is the same size. No person or group is favored. Everyone has an equal amount. So number 2, how can you find the fair share of arrowheads using the total number of arrowheads and division? This is just the word version of what we did here, mathematically. So I divided the total number of arrowheads, which was 20, okay, 20, by the number of students, which was 5, to get a fair share of 4. Make connections. The mean can also be seen as a kind of balance point. Miss Burnham's class holds a walkathon to help raise money to update the computer lab. 5 of the students walked 1, 2, 4, and 7 miles. The mean distance walked is 3 miles. Complete the dot plot of the data set. Circle the number that represents the mean. Complete the table to find the distances of the data points from the mean. So what we're going to do is we're going to look at these numbers and we're going to finish this dot plot. So we're going to look up here, and since there were 2 people that ran walked 1 mile, then we would put 2 dots above the 1. Okay, so those are done. And then we have 1 dot above the 2. We need 1 dot above the 4. And then 1 dot above the 7. So if I completed this dot plot, this is what it would look like completed. Circle the number that represents the mean, so the average. So let's look back at the top. There were 1, 2, 3, 4, 5 numbers. Okay, so first we need to add all of these numbers up. Okay, these go together to get 2. So 2 plus 2 is 4, plus 4 is 8. 8, 9, 10, 11, 12, 13, 14, 15. We have 15 as the total. And then there were 1, 2, 3, 4, 5 numbers. So we're going to take 15 divided by 5, which would give us 3. Okay. Circle the number that represents the mean. 3 is the average, so 3 is the mean. We're going to circle 3 in the dot plot. Complete the table to find the distances of the data points from the mean. Data point, 1 mile. 1 mile. So values less than the mean. So here was a 1. This was less than the mean. Here is the 2. Here, I'll use my highlighting tool. Right here. Whoop. One and 1 were under the mean. So that's here and here. Now 2 is also under the mean. Okay, now greater values than the mean were 4 and 7. Distance from the mean. So this is from 3 to whatever number it was. So if we're going from 3 to 1, we do 3 minus 1 would be, there's 2 miles in between, and that's where I'm getting this number. So then the distance between 1 mile and 3 miles is 2. The distance between 2 miles and 3 miles is 1. And then the distance between 4 and 3, so 4 minus 3 is 1. And the distance between 7 and 3 is 4. So the values greater than the mean, values less than the mean, and then the distance from the mean. Okay, that's something to double check to make sure that you have everything in the right place. The total distance from the mean for values less than the mean is 2 miles plus 2 miles plus 1 mile. So then we're going to add all of those together, and we're going to get 5. The total distance from the mean for values greater than the mean is 1 mile and 4 miles, which is 5 miles. Okay, so greater than the mean, we got that 1, and we got that here, 4. And we got these numbers here on this side. Okay. The total distance of the data values less than the mean is equal to the total distance of the data values greater than the mean. The mean represents a balance point for data values less than the mean and greater than the mean. Explain how you found the distance of each data value from the mean. Explain how you found the distance of each data value from the mean. I use the number line in the plot to count the number of units from each data value to the mean of 3. Can all of the values in the data set be greater than the mean? Explain why or why not. No. The answer is no. And one of the explanations could be if the value were greater than the mean, then the mean would not represent a balance point or a balance point somewhere in the middle. The mean is the average, so the average number that falls in the middle. So no. Share and show. Use counters to find the mean of the data set. On the first day of school, fundraisers, 5 students sell 1, 1, 2, 2, and 4 gift boxes of candy. So what you're going to do with your counters, if you have them, you're going to stack them all up. Then you're going to create 1, 2, 3, 4, 5 stacks. So 5 stacks. Rearrange the counter so that all of the 5 stacks have the same height. After rearranging every stack has 2 counters. So this is how we're going to figure this out if we do not have counters. 1 plus 1 plus 2 plus 2 plus 4. So those go together to make 2, 4, and 4. So let's add those together. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, your total number is 10 altogether, and we're going to divide that between 1, 2, 3, 4, 5. 10 divided by 5 is 2. Okay, right here. So the mean of the data set is 2. Make a dot plot for the data set and use it to check whether the given balance is a balance point of the data set. Rosanna's family have 0, 1, 1, 2, 2, and 12 pets at home. Rosanna says the mean of the data is 3. Is Rosanna correct? So what we're going to do is we're going to take these numbers and we're going to make them represent them on a dot plot. So there are 1 of her friends have 0 pets. 2 of her friends have 1 pet. 2 of her friends have 2 pets. And then 1 of her friends has 12 pets. So what we're going to do is we're going to take these numbers and we're going to add them up. 12, 2, 2, 1, 1, and 0. Okay. These go together to make 2. These go together to make 4. And this, we're going to keep this 12. So 12 and 4 is 16, 17, 18. We've got 18 is the total. And then we're going to go back and we're going to count how many numbers that we added. 1, 2, 3, 4, 5, 6. So 8 divided by 6, which would be 3. So we're looking at the answer here for the mean. Whoops, used the wrong tool. We're looking for the number here, which is the average or mean, which is 3. So is Rosanna correct? Yes, she's correct. So the total distance from 3, I'm going to go ahead and circle 3 there just so I can remember that's the mean. The total distance from 3 for data values less than 3 is 9. And then the total distance from 3 for data values greater than 3 is 9. The mean of 3 is a balance point. So Rosanna is correct. Number 3. 4 people go to lunch and the cost of their orders is $6, $9, $10, and $11. They want to split the bill evenly. Find each person's fair share. So what we're going to do is we're going to take these numbers, add them up, and then divide it between 4 people. So 6 and 9, 10, and 11. Let's add those up. 9 and 1 go together to get 10. 10 plus 6 is 16. So the total is $36. We're going to do $36 divided by 4. 4 goes into 36. Times 4, 16, 8. No, 9, actually. Okay, thought I lost it. Okay, so 4 goes into 36 9 times. 9 times 4 is 36. And then you get 0 remaining. So they want to split the bill evenly. Find each person's fair share. So each person should pay $9. Add all of the meals together then divide by 4. And that is how I got the answer there. Okay, use the tables 4 through 6. Save this for the end if you do not have time to do this. That is fine. But I just did the first problem for you in the problem-solving application because we will see problems like this often. So make sure if you don't know how to do this problem number 3 that you ask Mrs. Nicely or I to help you with it.